Hello, ladies and gentlemen. I hope you're well. This is Sig, and today we are looking at a fun little video because we're going to be looking at a new programming language. New for me anyway, I'm a complete beginner at this. We're going to do a complete getting started, getting installed, and writing your very first Hello World application in the Rust programming language. Now, you may have heard of Rust. It's very hyped at the moment. It's been very popular for the last many years. A lot of people use it for kind of lower level or kind of close to the hardware kind of writing. There's been a coding. There's been talks of it replacing C and C++ and so on. I'm not entirely convinced by all that, but I do think that it's worth trying it out. And I'd like to play around a bit and see if it could be a fun language. Now, don't worry too much. This channel is still a general programming channel. We're going to be doing lots of Go. We're going to be doing Haskell stuff still. We're going to be doing some C++. But, we like to try different languages, and I like to do different programming things. Generally, I just enjoy coding. So let's try some Rust. Now, if you haven't heard of Rust, there is a website here called rustlang.org, which is basically the official website. And as it says, a language empowering everyone to build reliable and efficient software. And this is a pretty good website to get started. Read about what Rust is. They keep saying Rust is blazing fast. That seems to be kind of one of their catchphrases. So let's see if that's actually the case, although we won't be benchmarking in a lot today. But let's just see if we can get started. So I figured we would walk through a complete reinstall of how to get started with Rust. So I've gone ahead, and if you can see, there's no Rust or anything on my machine right now, and I'm a complete beginner, so let's just see if we can get started together. So the first thing I would recommend doing is there is this really cool utility. If you are familiar with Haskell, you might know GHC up. And just like GHC up, there is a Rust up installer, which is basically a utility that allows you to installs Rust for you. So we're going to see if we can use this to install the Rust toolchain. If you are using any operating system, there's likely an operating system installer for you as well. A lot of the next distributions also ship Rust. But I like using Rust up. I think it's kind of the default tool and the default way of installing Rust on your machine. So let's try it out. I'm going to go ahead and copy this command. Always be careful when copying commands from the internet, but this one looks okay. And I'm going to go ahead and run this. So it's asking me, do you want to go ahead and run this? And then it says proceed with standard installation. We're just going to go ahead and do a standard installation. You can see it's installing a couple of things. Now, Cargo is a Rust build system. So it's the equivalent of something like Cabal in Haskell, or the Go one basically is just called Go, right? Or it's the Go compiler. But Cargo is kind of the bread and butter of Rust that we're going to be using. We're going to be using it for dependency management. We're going to be using it to build and run our code. I think that Clippy is a linter, so basically something that can tell us if our code could be a bit prettier or has some things that we could do better. And then there's things like Rust format, Rust docs, the std library or the standard library for Rust. Hopefully not an std, but that's what it says. So anyway, it says now Rust is installed now. Great. So let's see if it actually is. So if we go and say which cargo, we now have Rust installed or cargo installed in my home directory, in Sig's home directory, which means we should be able to start doing some Rust. And one thing we can do as well is we now have Rust up installed as well, so we can run Rust up show, and that will show basically the latest or which version of Rust up has installed. And we can actually compare that to the version of the Rust C compiler. You can see that these two versions go hand in hand. So Rust up has installed this for us, and this is a version of the compiler that we have. And Rust up is a really handy utility. It does a lot of stuff. You can do something like Rust up update to update Rust for you and so on and so forth. But now we have it installed. So let's go ahead and create our first project. And I figure what we do is we're going to build a really simple application that's just a guessing game that lets you basically input a number, and then it will compare it to a randomly generated number, and it'll tell you if you are above or below it, or if you've hit the number on the spot. And hopefully this will teach us a little bit about Rust, because like I said, I'm a complete beginner. So, we're in this together, basically. I will say shout out to a book from MIT, which is an Introduction to Rust Programming Language. That's where I got this example, or at least the inspiration for it. I'll put a link to that in the description below. So let's get going. Let's start by creating our first new Rust project. So using Cargo, we can say Cargo new, and then let's just call this guessing name. And then we're going to say we just want a binary, so we're just going to create an executable. So what this will do is Cargo should go ahead and create a new directory for us. So we should now be able to go into guessing game. And if we run ls, you can see it created 2 files for us. So let's get into Nearby and get going on this. So go ahead and get rid of this. And let's see what we got. So let me just make this a little bit bigger for you to see. There we go. So what Cargo has created for us is a couple of things. We've got a source folder with a main.rs, which is our main Rust file that we're working with. It also went ahead and created a gitignore, a cargo lock, and a cargo tuml file for us. So let's start by looking at main.source, or main.rs, sorry. And you can see it's pretty simple. It has a println macro, and it says hello world. This is kind of your standard bread and butter hello world main function. This will be the main entry point of the application. And if we look at cargo tuml, there's a little bit of metadata in here. It says the name is guessing game, version 0.1, edition 2021. I'm guessing that's some kind of Rust edition. And then dependencies is blank. We don't have any dependencies. Cool. So far, so good. Let's see if we can actually run this. So cargo has a couple of ways of being invoked. We can say cargo build, and it says finished very quickly. That will build an executable and store it, I think, inside a target directory. There it is. It's just hidden in neobim because I have hidden Git files to not show. But we can also just do cargo run, which is the equivalent of something like go run, right? So just like go build and go run, if you're coming from the Go world, we can do cargo build and cargo run. So if we do cargo run, we get a little bit of output from the linker on the compiler, and then it says running the executable, and it says hello world. Cool. So let's start looking at writing our first Rust code. This is a little bit scary, but let's get into it. So I think one thing, again, I'm a complete beginner at this. I literally just started reading that book a little bit. One thing I found out is these macros, right? So these macros are basically handy little snippets of code. And if I bring up the macro information here about println with the exclamation mark, it says that it actually does a little bit more under the hood. It's not just like writing to standard out, like you would maybe expect from a println function. It's actually also using sort of locking on the thread to make sure that that standard out isn't being flushed by multiple threads. So what you may have seen if you've done any kind of concurrency programming is you might see multiple threads writing to standard out, and all the sort of output characters become all jumbled up, and it's sort of nonsense. So this should allow, it's basically using a mutex to basically lock the standard out and say, I'm the thread that's writing now, and that's how we get hello world. So it's just a handy little macro, and I think Rust uses these macros quite heavily, but we'll hopefully find out more as we go along. So let's start by writing a bit of code. So what I was saying earlier is we're going to write a little game, and it's going to be called Guess the Number. And what it will do is it will essentially allow you to input a number, and then can compare that to a number that we've generated based on a random number, and then allow you to kind of keep going until you guess the right number. Let's start with a little bit of basic syntax. So ironically, or maybe not ironically, if you're familiar with Haskell, Rust borrows a lot of stuff from Haskell. So obviously they're different kind of languages in a paradigm sense. So Rust is a different, I wouldn't say strictly object-oriented language, but it certainly is more imperative than Haskell is, and it's less abstracted. But it borrows a lot of its type system, a lot of its pattern matching, a lot of its syntax really from Haskell. So the let keyword you may be familiar with from Haskell, from the IO monad, but in Rust, it's the way that we declare variables. So we declare patterns of variables. So we can say something like, let guess, and then we're going to say, this is a new string. So how do we do that? Like so. Also, if you're used to Go, Rust uses semicolons. So we're back in semicolon land, which I don't really mind. I've missed the semicolons when I was writing Rust. So this should actually create a new variable called guess, which is a new empty string, right? Cool. However, there's a caveat already, which is that Rust is immutable, or like, let's say it favors immutability. Again, kind of like Haskell, but it sort of has this concept of variables are immutable by default. If you need your variable to be mutable, you need to specify that this is a mutable variable. It's sort of the opposite of const in C++ and C, right? It's basically saying, like, rather than declaring everything as const is the default, you have to say it's not mutable. When in this case, we want it to be mutable, so it's going to be mutable. So let's see how we could get some input. Let's start with using IO. So actually, before we do that, let's import our first dependency, or our first import in this Rust program. So you saw earlier when we installed Rust that there was actually a standard library, a Rust standard, a Rust std that we pulled in. So that's the standard kind of prelude of Rust. And you can use functions from that standard library by importing them. So this is the equivalent of importing them in something like Go or Haskell, but we are using the use moniker to say we're using the IO crate, I believe it's called, of the module, sorry, the IO module. I'm still learning my Rust terminology. The IO module of the standard library. So in this IO module, there are some useful things. For example, there's a standard in function, which allows us to do a couple of things. So let's see how far we get. So the first thing we can do, and I will walk through this in a second, is we want to be able to read some input. And we'll start by doing something like this. Let's see if it's happy with that. So what have we done here? Well, we've called standard in from the IO module, right? So standard in is a function which is used, well, it's similar to any other standard in function you may have worked with. And then we say we're going to read a line and we're going to bind that line. So this is the ampersand operator. So we're going to bind that line to basically the address of a mutable output, which in this case is guess. And this is the mutable string that we created up here. However, we're also using a nice little Rust feature, which is that something like readline, maybe if I bring up the documentation on readline, is you can see returns a result. So result is kind of like, you might compare it to an either, for example, in Haskell. It's basically a result that can be one thing or the other, and the other thing is typically an error. And so Rust has a bunch of really handy little helper functions that allow us to work with these results. And we'll walk through some of them in this little tutorial. But again, I'm very new to this. It's literally my first Rust program. So we're learning on the fly, guys, so bear with me. But one thing that I've learned is you can call something like expect, and this will act on the error case. So basically, what will happen here is that if the error is returned by readline, like it failed to read the line, then this is the value that it will return, which is failed to read line, we should put in there, right? So we're kind of handling the case in that sense. So let's go ahead and do another print line. And let's say you guessed, and then we'll just put in, this is just a formatting thing, and we'll put in guess again. Okay. Now, let's see if this actually works, right? So let's clear this and do a cargo run. So it says guess the number, and then I'll put in 12, and it says you guessed 12. Cool. Pretty good start, right? Let's do a couple of things first. So guess the number. Let's just say this is going to be the name of our game, right? And then we'll put in up here, let's put in another println, and we'll say, please input your number, like so. And then it's already complaining, saying you need a semicolon. Gets very mad at me. So now we should have yes number at the top, and then please input your number. And then we should read the next line and bind that input to our mutable string guess, right? So far, so good. Now, what do we need? Let's start by doing something interesting. So this is all using the Rust standard library, using, a variable that we've declared, using the IO module and standard in, all good. Let's work with dependencies. So we have some files over here. We talked a little bit about cargo.toml. So cargo.toml is essentially your sort of project file, or the thing that that describes the project or the crate that you're building here. And a crate can have a lot of dependencies, right? And the way you actually define dependencies is you basically name them, and then you give them a version. And you can see that I have a nifty little plugin that eventually checks or immediately checks what the version of the crate, or the most recent version of the crate is. And I think if I take a lower version, it will still say there. And so actually there's a higher version available, which is 0.8.5. But I can add a dependency, and the dependency that I want to add is the rand dependency. So this is a module that allows us, or maybe it's a crate. Again, I'm still learning some of the functionality or the terminology in Rust, so bear with me. But basically what this is it is a external dependency that our project can pull in. And the way we can use it, there's a couple of things we can do, but we can say extern create rand, right? So now we're telling the compiler that we want to use that extern create. And we also want to use specifically from rand, just like we did with standard IO, we want to use the RNG module, right? Okay. So now it's saying remove it because I'm not using it in my code. That's great. But let's see how we actually pull this down. So if I now run cargo build, what you'll see is that it's not just building. It's actually gone ahead and it's pulled in a bunch of dependencies. If we scroll up here and look at it, you can see that it's compiling and it's actually pulling in dependencies. It's pulling in random core and some other dependencies that the rand create has introduced. And then it's given us a warning saying, stop importing it. You're not using it. Fine. So what we have done there is we've declared a dependency and we've built our program, and Cargo has automatically pulled down that dependency and made it available and linked it to our program. So now we can actually use it. So what we want to do, I think what we want to do is we want to start by creating a secret number that the user is supposed to guess, right? So let's try that out. Let's do secret number. And again, from what I've learned, Rust is all about snake case. So they wanted to use snake case parameters. And the rand crate that we pulled in has a cool little function called thread RNG, which retrieve the lazily initialized thread local random numbers. It's basically a random number generator. And then you can generate a number within a range. And a range, again, if you're familiar with Haskell, is pretty cool. You can do something like this and actually declare a range like so, right? So this will now, we should now have a secret number which should be within the range 1 to 20. So just for kicks, we're obviously going to remove this, but we can start by printing this out and say, what is the secret number that we've generated? Let's go ahead and do that. Like so. Oops, and clear this, and let's cargo run our little program. And now it says secret number is 13, and I can put in 13, and it says you guessed 13. Okay, and if we run it again, secret number is 5, and run it again, secret number is 6. So it will basically generate a secret number within our little range here, which is cool. Now, what we want to do as our little game is we want to compare the number that we put in, or that the user put in, to the secret number that we generated. So we obviously don't really want to print it. So let's go ahead and remove that println. We just want to see that it actually worked. And let's go ahead and see if we can compare it. Now, there's a couple of things we need to do. First thing is that we've said that guess is actually a string, right? Because read line binds a string from the standard out. So the first thing we need to do is we need to change guess to be a integer. Or in this case, we can actually do an unsigned integer because we expect this to be positive, right? So how do we do that? Let's say, rather than having guess be bound like this, we can actually go ahead and say, let guess, and then we're going to declare specifically that it's an unsigned 30, so a 32-bit unsigned integer. We're going to use something called pattern matching. So pattern matching is a big concept in Rust, and it's essentially a way of using some syntax to pattern match different scenarios in our program. And kind of similar to what we talked about earlier with the result that we worked at. Pattern matching, or in this case, what we're pattern matching is the result coming back from attempting to parse, which if we look at parse here, so parse returns a result and tries to sort of go from one type to the other, right? So we're saying now, try to parse the string guess into the unsigned 32 guess. And if that returns an okay result, which is kind of the first tuple of the result that was returned, then everything's good, and we can actually go ahead and say, go ahead and return the number that you got out of there. So we'll talk about this a little more in a second. But if there's an error, like so, then we can actually go ahead and, what should we do? I think for now, let's just print out an error and say something went horribly wrong, and we'll say, please input a number, right? Like so. Okay, so let's see, mismatch, expected U32. All right, it actually wants a number, so let's go ahead. Let's see, how do we do this? I think the so it wants us to return, I suppose, the same type. Again, sorry, we're learning on the job here, but it wants us to essentially return the same type as we unwrapped from the OK result. So I think what we can do, if we just have a look, is we can actually well, actually, for now, let's get rid of this handling and we'll just do what we did earlier, which is use the expect. So the expect function here, and we'll say, please provide, or please type a number, right? So we'll basically throw a little fit. Whoops. And let's see if that will work. Try removing this match. All right, we don't want to match anymore. So now we have a guess that should be an integer, or we throw a an error, but we will introduce the match again later. But what I wanted to do first is I wanted to use let's use a different example of match, which is what we want to do now is you want to compare those two numbers, right? So we've got guess as an unsigned 32, the number that the user input and guessed, and now we want to compare it to the secret number. And Rust has a pretty cool utility for this, which is again in the standard library, and it's basically the compare ordering. So CMP, right, is utilities for comparing and ordering, and then we've got ordering itself. So what that allows us to do is to do something like this. So let's call guess, and then let's call CMP, which is compare it. Then we're going to give it something to compare it to. In this case, we're comparing it to secret number. And then we want to pattern match on the result of this. And if we look at the result, if I could type this correctly, it actually returns, if you look at CMP, it actually returns an ordering. And what do those orderings look like? Well, we can pattern match on the order and result. So we can say ordering less, like so. And this will actually return, or this will pattern match against the result being an ordering of less. So basically, our guess is less than the secret number. Likewise, we've got equal. So let's go ahead and implement that and say println, and we'll say, oh, sorry, not equal, greater, sorry. So we'll say greater than, and then finally we've got equal. And when it actually equals, we can go ahead and say, you got it, you win. Because you've actually matched the correct, number. So let's see if this actually compiles, or if we've made a bunch of issues. So it definitely compiles. Let's put in 10, and it says too small, right? And immediately we got it wrong. So let's try again. 12, you win. Okay. What are the odds? I actually guessed it on the right go. Let's run it again. 7, too big, right? So 7 wasn't quite big enough. Let's try 5, too small. So it seems to work, but immediately we've kind of encountered one of the limitations of this little game is that it gives you one guess, and if you don't get it right, it exits the game, right? Because after this, it just exits, the main function exits, and it takes you out the game. So let's do a final thing here as this little getting started example, which is we want to give the user multiple tries of this. So the easiest way to do that is we can actually use a loop. So just like other imperative languages, Rust has a loop or has multiple loops, but perhaps the most easy one is just using a loop. It's kind of like a while loop, or just, it just loops indefinitely unless you tell it to break. And let's tell it to break, and we'll break if the user actually guesses the number. So crucially, what we've done is we create the secret number once outside the loop, and then we just loop and loop and loop until you actually guess the number. So let's see if this works. So let's clear this and say carbo run. Please input your number, 12. Too big. Please input your number again. So we're now looping. Too big. Okay, it says it's less than 5. Let's try again. Still too big. 3, you win. Okay, so we got it at 3. Let's run it again. 12. Okay, right off the bat, 12 was the number. Let's try test. Boom. Panic, right? The whole thing went haywire. It said you guessed test because it was, it was a valid string, but basically our whole thing blew up. And this is what we wanted, that pattern matching that we had earlier, which I think we should still try to implement. So let's get rid of this, and this be the final thing that we do. And let's go back to seeing if we can implement the pattern match on this, because we don't want this to blow up and actually crash our game if this goes wrong. So kind of like I was doing earlier, let's just start out with this, and we're going to say guess is an unset integer of 32 bits, but we're actually going to call this parse function, and then we're going to pattern match on the result. And again, the result is either going to be OK and some kind of result, so something wrapped in OK, and in this case, it'll be a number, or it's going to be an error. And if it's an error, we can now do one of two things. Let's create a little bracket here, and we're going to print out the fact that it's an error. I'm going to say error, please input a number. And then what we can do now is, whoops, if I could just type things correctly, what we can do now is we can actually just hit continue, right? And then again, this is a big kind of decoration, so we put a semicolon at the end. So now it's no longer complaining, because it will essentially continue now, and eventually the outputs of these two will be the same, right? Because then we're now continuing, we're going to loop on, we're going to try again. So let's see if this actually works. So we'll call the run again, see that it still works. Too big, too small, 7, too small, 8, 9, 11, too big, must be 10 then, right? You win, great. Let's try it again. Cargo run, and this time start by 12, fine, and let's do test. Then it says error, please input a number, and then it loops, please input your number. So we try again, 12 again, too big. Test, no. This day we can go indefinitely, as far as we want. So that was a little introduction to getting started with Rust, installing it, and writing our very first little application. Bear with me, I am still learning Rust. I literally looked at it for the first time this week, so it will be a fun little thing to play around with. I will be hopefully doing some more videos on Rust, and some more Go videos, and some more Haskell videos, and all the good stuff. But I am enjoying how similar it is to Haskell in some ways, and how modern it is in other ways. The tooling feels kind of like Go, like we've got a TOML file, which is not unlike the Go mod file. This is not unlike the Go sum file. The cargo build system and Rust up and all that are very similar, I think, in as to how Go is. I think the portability of Rust is probably a lot better than Haskell. I'm quite enjoying it, and I hope you enjoyed this little video too. And thanks for watching, guys. Bye-bye.